Welcome to Cognito Key. You know, in the world of electronics, some components seem to get all the glory. But what if I told you there's a tiny, unassuming device out there with a hidden superpower? Well, today, we're unlocking the secret of the Unijunction Transistor, or as we'll call it, the UJT.
So here's what we've got lined up. We'll start with the absolute basics of what a UJT is, then we'll peek inside to see how it's actually made. After that, we'll get into the really cool part, how it works, and uncover its secret weapon, something called negative resistance. And finally, we'll see how this powerful little component is used out in the real world.
All right, first things first, what in the world is a unijunction transistor? Let's break it down.
The name really gives it away. Unijunction. See, unlike most transistors that have two p-n junctions, the UJT has just one. And that single junction is the key to everything that makes it so unique.
So the UJT has three connection points, or terminals, an emitter, base 1, and base 2. Because it has those two bases, you'll sometimes hear it called a double base diode. But the most important thing to remember, its real superpower, is that it has a negative resistance trait. We'll see exactly why that's so special in just a bit. Okay, so how is this unique little component even built? Let's take a look inside. Imagine a small bar of silicon that has just a few extra electrons. That makes it what we call N-type. Then, a tiny bit of material with holes where electrons can go is fused into it, creating a P-type region. This forms that single P-N junction, which is really the heart of the UJT. The two ends of that silicon bar become our bases, B1 and B2, and that little P-type spot becomes our emitter. Now, when you see it in a circuit diagram, the UJT has this unique symbol. That little angled arrow on the emitter always points towards the base, and it's kind of hinting at its special triggering ability.
Now for the really fun part. How does this thing actually work? Let's walk through its unique triggering process.
You know, the easiest way to understand what's going on is to look at this simplified circuit. You can think of the UJT as a simple diode that's connected to a voltage divider. That silicon bar we talked about basically acts like two resistors, RB1 and RB2. But here is the crucial detail. The resistance of RB1 isn't fixed, it's variable, and that changes everything. This brings us to a kind of fancy-sounding term, the intrinsic standoff ratio, or eta. All this is a built-in property of the UJT that determines the exact voltage at which it will suddenly switch on. Think of it like a preset tripwire. So here's the play-by-play. First, we apply a voltage across the two bases. Then, we start to slowly increase the voltage at the emitter. We keep increasing it until, bam, it hits a very specific point, called the peak point voltage. At that exact moment, the UJT triggers, and a rush of current flows through the emitter. Now, this is where the magic happens. That sudden flow of current causes the resistance of RB1 to drop like a rock.
This dramatic drop in resistance is the whole key to the UJT's unique superpower. It's a characteristic that makes it absolutely invaluable in things like timing and oscillator circuits.
So what really makes this so special? What is the secret we've been talking about?
This graph right here reveals the entire secret. You can see three different regions: cutoff, saturation, and the most important one, the negative resistance region. Now look closely. In this area, as the current increases, the voltage actually decreases. That is the complete opposite of a normal resistor, and it's what makes the UJT so incredibly useful.
This negative resistance characteristic is exactly what makes the UJT such a fantastic electronic switch. It can turn on really quickly and super reliably, which makes it perfect for all sorts of different applications.
So, you take this unique trait and you combine it with the fact that it's low cost, it's efficient, and it has a super stable and predictable trigger point, well, you end up with a really powerful and versatile little component. Okay, so we've seen the theory. Now let's see where the UJT actually shines out in the real world.
Because its switching is so reliable, the UJT is perfect for triggering more powerful components, like thyristors. It's also the star of the show in things called relaxation oscillators, where it's used to create timing pulses that can power everything from flashing lights to old-school musical synthesizers. Its precise voltage trigger also makes it a great choice for circuits that protect against overvoltage. The UJT is just a great reminder that even the simplest-looking components can have some incredible power hidden inside. It kind of makes you wonder, what other electronic secrets are just waiting to be discovered?
If you enjoyed this explanation and unlocking the UJT secrets with us, please subscribe to Cognito Key, and don't forget to like and share this video. Thank you for watching.